Most connected homes rely on a specific equipment, the home gateway or the set-top box. These boxes allow customers to access internet through a set of dedicated services. Multimedia, data, voice, television, all these streams go through the home gateway. Today, this equipment is always on 24 hours a day, and it consumes a lot of electrical power, between 15 to 30 watts, idle or not, used or not. So what if we moved all these boxes to servers in the cloud, while creating new virtual home gateway, making service easier to be controlled by network operator, while reducing energy and complexity? Hundreds of thousands of boxes could be replaced by a much smaller number of servers, more control and less energy. In addition to virtualizing these boxes, we've developed a new distributed architecture for the servers, which allow even greater energy improvement. This architecture allows us to shut down some of the servers during slow times, thus conserving power, and then turning only servers back on when CPU-intensive applications or bandwidth-intensive activities, such as HD streaming, are required. This allows a more efficient sharing of the resources and lead to a reduction of the power consumption by the residential access network by 19%. Without any additional changes or other technology improvement, we could save about 330 megawatts of electrical power or 2.9 terawatt-hour of electricity on an annual basis. This is the equivalent of 800,000 typical households.
The Virtual Home Gateway project has demonstrated that this level of reduction is indeed feasible, and we have built a lab demonstration to validate our concept. We can host 200 Virtual Home Gateways on a single server consuming 200 watts. The Virtual Home Gateways are all active and handle video transmission and forwarding to 200 clients. The per home power consumption of 1 watt for a Virtual Home Gateway has to be compared to the equivalent home gateway data processing power consumption of about 2.4 watts in today's networks. In addition to demonstrating the feasibility of the virtualization concept, we have also addressed the scalability issue through distributed server architecture. The main concepts involve hosting the Virtual Home Gateway functionalities on multiple servers that can be efficiently shared and turned on and off as needed by the traffic demands. When the overall gateway usage is low, that is, when only a few customers are requesting services, the majority of the virtual gateways are in idle mode and can be consolidated on a single server. The remaining servers can then be switched off for further energy savings. However, when more in-home subscribers connect to the network or require more services consuming a lot of processing power, like deep packet inspection or significant network bandwidth like HD streaming, the associated Virtual Home Gateway will need to be activated and will consume additional resources. As the number of active subscribers increases, a single server will not be able to support all the Virtual Home Gateways, so function will be migrated to another available server that can more effectively handle the load. With this novel approach, we will be able to provide the optimal quality of service to all the subscribers while activating only the minimum required number of servers with the overall minimum amount of energy. This ensures that we eliminate any wasted energy by only using resources if and when they are needed. In addition to the significant flexibility and associated energy savings, virtualization provides further major benefits to service providers from an operational point of view. These benefits will also positively affect the end customer as well. First, maintenance and upgrades will be much easier, as the gateways now all reside in an easily controlled and updated network operation centers. There is no need to dispatch tech support to customer home. Second, greater service availability resilience to faults can be guaranteed since the services are hosted on multiple distributed servers and can be easily migrated. We are very proud of this accomplishment that proves the value of virtualization from a number of perspectives, including its value for the network and service energy efficiency. The benefits of the technology will only increase with increased number of users, dynamic application, services and traffic flows. In the GreenTouch Green method, we envision a network for 2020 with an 8-fold increase in the wireline access traffic compared to 2010. This new technology, along with expected network and server hardware improvements, can provide a 30-fold improvement in the network energy efficiency in future network, corresponding to a 73% reduction in power compared to a 2010 state-of-the-art network.